Before we begin, let me show you the map of where we're going. What you're looking at is a dependency graph. Every node is a step in a derivation. Every arrow says, this step requires that one. The white nodes at the top are foundations. The colored nodes below build structure, invariance, dynamics, moved, and finally at the very bottom, mathematics and physics themselves. The claim is extraordinary, starting from literally nothing, the nothingness symbol, meaning no information at all. Every step that follows is forced, not chosen, not designed, forced by a single axiom about what it means for a distinction to exist. Every node in this graph, including the universal evaluator at step 3, is forced by the completeness requirement of A0. Let's begin. Imagine nothing, not empty space, that's something. Not darkness that requires light to be absent from, truly nothing. No objects, no properties, no distinctions of any kind. We write this as the bottom symbol. It means no admissible distinctions exist. Watch what happens when we try to find a distinction here. A search expands outward and collapses. There's nothing to find. You might think, start somewhere else. Start with numbers, or sets, or particles. But any other starting point already assumes structure. Numbers assume counting. Sets assume membership. Particles assume space. The nothingness symbol is the unique, unfalsifiable starting point. You can't prove nothingness wrong, because there's nothing there to be wrong about. But this raises a question. If we're starting from nothing, how do we get anything? The answer is axiom A0. A distinction is admissible if and only if a finite witness procedure can separate it. If witnesses must be finite, then the descriptions they operate on must be finite too. You can't witness an infinite object in finite time. So every object in our universe must be finitely describable. Finite descriptions over an alphabet. The minimal, non-trivial alphabet has two symbols, 0 and 1. So the carrier set is forced to be D star, the set of all finite bit strings. Look at this binary tree. The root is the empty string epsilon. Every finite bit string lives somewhere in this tree. This is our entire universe of describable objects. Long. We chose binary, but we could have used ternary, or any other finite alphabet. This choice is what we'll later call gauge. It doesn't matter which alphabet we pick, because they're all intertranslatable. Look at this raw bit stream. Where do the boundaries between objects fall? The parsing is ambiguous. In our closed universe, with no external delimiters, programs must be self-delimiting. They must contain within themselves the information about where they end. This is the prefix-free condition. No valid program is a prefix of another. Look at this tree. The green leaves are code words. No leaf is an ancestor of any other leaf. Prefix-free codes obey the Kraft inequality. The sum over all code words of 2 to the minus their length is at most 1. Watch, we tile the unit interval. Each code word takes up a fraction. They tile perfectly. No overlap. The Kraft inequality holds. Self-delimiting syntax is the only way to have unambiguous parsing in a closed universe. Now we need tests, procedures that can distinguish one object from another. But remember, a 0, no external input allowed. The tests must come from within the system. Take a program P and an input X, both finite bit strings. Feed them into a universal evaluator, U. The output gives us a test. Tau sub P of X equals the decode of U applied to P and X. Programs generate tests. The system tests itself. Now, where does U come from? A 0 demands all possible finite witness procedures. All possible. That word, all, requires closure under composition. The closure of all finite procedures over D star is a universal evaluator. U isn't assumed from outside. It's forced by a 0's own completeness requirement. If you demand every finite test must be admissible, you've already demanded a machine that can run every finite test. We record them. Every time a test tau produces an outcome, we write down the pair tau comma A in a ledger L. Watch, test tau 1 fires, produces outcome A1. The pair slides into the ledger. A lock appears. This entry is permanent. The ledger is append only. You can write, but you cannot delete, ever. If you could erase records, you could unmake distinctions, and the universe would have no stable history. Each record links to the previous via a hash, a simplified blockchain. The chain ensures integrity. Tampering with any past record would break all subsequent hashes. The ledger is the foundation of truth. Without it, distinctions are ephemeral. With it, they become facts. Now we reach perhaps the deepest idea in this whole derivation. How does truth emerge from a ledger of test results after all tests have been applied? We're left with clusters of objects that no recorded test can distinguish. Objects in the same cluster are by A0 identical for all purposes. These clusters are equivalence classes. The full collection of classes is the truth quotient. Pi star of L equals D star modulo the equivalence relation. Watch the dots merge. Many objects collapse into few equivalence classes. This compression from raw objects to truth classes is what we call pi star closure. It's how reality crystallizes from data. Every transformation on equivalence classes can be decomposed into exactly two operations: merge and relabel. The function f maps source to target. Some elements land on the same target. That's the merge step. Multiple sources converge to one image. Then the relabel step, each merged image gets placed into the target. Every function f factors as f equals iota composed with pi. This is the image factorization theorem. It tells us that in our universe there are exactly two primitive operations. Merge, many become one. Relabel, one moves to a new name. No third type of transformation exists. The ledger is append only. Each new record is an irreversible commitment. This asymmetry creates something profound: time. Here's the consistency fiber W, the set of all states compatible with the current ledger. Right now, 16 possibilities survive. A test fires, the fiber shrinks to 8 survivors. The cost of that observation is delta t equals log base 2 of 16 over 8, which is 1 bit. That's time, not a ticking clock on a wall, but the irreversible cost of committing to an observation. Because the fiber can only shrink, delta t is always non-negative. This is the second law of thermodynamics, emerging from the simple fact that the ledger is append only. Time always moves forward, because you cannot unknow what you've learned. Each test costs resources. The budget is finite, so as we run tests, the set of affordable tests can only shrink. Watch the budget bar deplete. Each test drains resources and removes itself from the available set. The step function shows the size of the feasible test set over time. It can only decrease. Each test costs irreversible resources, and in a closed system with no external energy input, the test budget is finite. Eventually, the bar hits zero. Only constant tests remain, tests that produce the same output regardless of input, tests that distinguish nothing. What happens when you can't distinguish anything anymore? When only constant tests remain, no feasible test can tell any two things apart. Every equivalence class merges into one. The size of pi star of L equals 1. There is exactly one equivalence class. Everything is indistinguishable. This is operational nothingness. But this is a different nothingness from where we started. At the beginning, there were no distinctions because there were no criteria. Here, there are no distinctions because there's no budget. And look at the grand circle. Nothingness leads to structure, which leads to operational nothingness, which connects back to the beginning. The derivation is cyclic. The universe begins in nothing, builds structure, and returns to nothing. Are all the labels we've been using real? Do the names A, B, C actually matter? Apply a relabeling. A maps to alpha, B to beta, C to gamma. Run every feasible test on both versions. The outcomes are identical. No test can detect the relabeling. By A0, an untestable difference is no difference at all. So this is a gauge transformation, a physically meaningless change of representation. The collection of all such relabelings forms a groupoid, GT. The physical output, the real content, is what remains after removing all gauge transformations. Only gauge invariant structure is real. Everything else is just labels. Consider a ledger L. We can apply dynamics N, then take the truth quotient Q, or we can take Q first and then apply N. Do we get the same result? We must. Watch the diamond. Both paths arrive at the same bottom node. N composed with Q equals Q composed with N. They commute, the diamond closes. If they didn't commute, the order would matter. But the order itself is unrecorded metadata, an untestable distinction, and untestable distinctions violate A0, so commutativity is forced. Does time have a global ordering? Is there a universal clock? Look at this Hass diagram. Events are dots. Arrows are causal dependencies. Event 2 depends on event 1's output, so event 1 must happen before event 2. But events 3 and 5, no causal connection. Neither depends on the other. A global clock would order all events linearly, but which ordering? Both are valid. No test can distinguish them. So a global clock is gauge, an untestable structure, forbidden by a zero. What survives is only the partial order of causal dependency. Different linear extensions are all gauge equivalent. Only the causal structure is real. The system needs a controller N to select the next test. But what information can N use? Path A, apply pi first, then let N decide. Path B, let N see the raw state, decide, then apply pi. These must produce the same result. If the controller uses gauge-dependent information, it would make different decisions for gauge-equivalent states. That's an untestable distinction. Forbidden by A0, the controller must be blind to gauge. It can only use equivalence classes, never raw labels. For any question, we search the consistency fiber for answers. Two things can happen. Case 1, only one answer survives all tests. That answer is unique, trait value +1. Case 2, multiple answers survive. This is the omega frontier, trait value 0. What we absolutely cannot do is guess. If 3 answers are equally consistent with all evidence, picking one at random would be an arbitrary choice among indistinguishables. Exactly what a 0 forbids. Instead, when we hit omega, we return 3 things: the surviving answer family, the minimal separator test, and the resource gap. Unique or omega. Never guess. When we're on the omega frontier with multiple survivors, which test should we run next? The answer is deterministic, the Bellman minimax. For each candidate test, Tawa, compute its cost, and the worst case number of survivors over all possible outcomes. The total score is the sum. Pick the test with the minimum total score. This is the optimal test, the one that makes the most progress for the least cost, even in the worst case. It's not a heuristic or a guess. It's the unique minimax optimal strategy. Now, put it all together. The universe engine is a closed loop with 6 stations. Tau star, select the optimal test via Bellman minimax. A, observe the outcome. L, record the pair in the ledger. T, increment time by the cost delta T. Q, recompute the truth quotient. W, update the consistency fiber. Then, repeat. Watch the dot travel the loop. Cycle 1, fiber starts at 16, shrinks to 8. Cycle 2, 8 to 4. Cycle 3, 4 to 1. The fiber reaches size 1, operational nothingness. The engine halts. This loop is the unique dynamics that preserves a 0, while maximally distinguishing states. The engine creates local order by exporting disorder. The system organizes itself by pushing entropy into the environment. But the total system plus environment can only increase. Delta S system plus delta S environment is greater than or equal to 0. The second law. This isn't a statistical tendency. It's forced by ledger irreversibility. The ledger can only grow. Growth means commitment. Commitment means entropy production. The arrow of time and the growth of entropy. The ledger needs a concrete encoding. Assign each record a unique prime number. Record 1 gets prime 2. Record 2 gets prime 3. Record 3 gets 5. Record 4 gets 7. The ledger integer is the product. L equals 2 cubed times 3 times 5 squared times 7, which equals 4200. Now membership becomes divisibility. Record R is in L if and only if its prime divides L. Union is LCM. Intersection is GCD. Long fundamental theorem of arithmetic guarantees unique factorization. There's exactly one way to decompose L into its prime factors. No ambiguity, no representation bugs. The system makes a completeness guarantee. For any question with a finite witness, either the answer count equals 1 and you get unique, the answer, its witness, and a verification receipt, or the answer count is greater than 1 and you get omega, the surviving family, the minimal separator test, and the resource gap. There is no third option. Guessing, a 0 violation. Silence, conceals data, violates witnessability. Probabilistic hedge, confidence scores lack finite witnesses. Only unique and omega are 0 compliant. This binary is exhaustive. What is mathematics? In this framework, mathematics is the gauge-invariant language. It's built from 5 structures that emerged in the derivation: tests, quotients, closures, cost, and frontiers. All 5 converge on a single center: mathematics. Watch the gauge filter. Raw objects enter from the left. They pass through the GT barrier. The number 3 passes through. It's the same in every representation. The word 3 is blocked. The word dry is blocked. These are all gauge-dependent labels for the same invariant structure. Mathematical truth is precisely the structure that survives all representational changes. And physics? Physics is the same kernel, the same universe engine loop, but with one difference: the tests are physical. Delta math consists of abstract tests, proofs, deductions, logical arguments. Delta physics consists of physical experiments, measurements, observations, particle collisions. Both plug into the same engine. Both produce unique, or omega. The kernel is shared. From this framework, physics phenomena emerge: quantum superposition, the omega frontier, where multiple states survive until measured; the arrow of time, ledger irreversibility; wave function collapse, the fiber shrinking to a singleton after measurement. The grand circle completes, from nothingness through forced structure to mathematics and physics. What have we seen? Starting from literally nothing, the nothingness symbol, and a single axiom about finite witnessability, the derivation forces a sequence of structures: a carrier set, a syntax, tests, a ledger, truth, time, gauge invariance, dynamics, and finally, mathematics and physics, as 2 faces of the same computational kernel. Every step, including the universal evaluator at step 3, is forced by the requirement of finite witnessability. From the bare assertion that distinction requires finite witness, moved an entire universe of structure follows, not by design, by necessity.